I would bet you my salvaged components collection that without looking anywhere else, you have a button in your field of view right now. Why? Because buttons are everywhere. I mean, I probably don't need to explain how useful they are. And today, you'll learn to code them with Arduino to be able to interact with whatever quirky devices you can come up with. They actually gave me quite a lot of trouble initially, so in this video, I'll try to correct my mistakes and give you the right foundation for understanding these things. Let's get right into it! To understand what we're working with, let's quickly look at what the inside of a button looks like. A button is literally just a switch, except instead of having a lever to lock it in one position or using electricity to switch like we saw in the last video, you push the button, switch closes, electricity flows. You lift the finger, switch opens, electricity doesn't flow. However, you'll notice the buttons we use with Arduino are a bit weird in two ways, because why do they have 4 legs? And why are they bent? Well, don't panic, everything has a purpose, and in this case, they're made like this so they'll fit neatly into a breadboard. Isn't that convenient? As for how the 4 legs work, it's literally the same as a 2-legged one, because each leg on one side is connected to the one on the other side. So first, we'll test them with a codeless approach, simply turning on an LED when we press the button. At this point, you might actually be able to come up with the wiring yourself, so if you're up for an extra challenge, feel free to pause the video and give it a try. Okay, so what we'll do is place our button anywhere. Just remember to place the legs to each side of the switch on different lines so they're not already connected. Connect 5 volts to a line, pass a resistor from that line to one of our button's lines so our LED doesn't explode, and then connect the LED's positive to the other button's line. Finally, connect GND to the LED's negative and our wiring is done. Simple enough. Now, if you press the button, the LED lights up. Nice! Now, let's work with some code. And in fact, buttons will enable us to do so much that you're actually about to learn some incredibly useful pieces of syntax. But first, to interact with our button, we're gonna simplify our wiring even more. Simply connect one side to GND and the other side to any pin. Why GND and not 5 volts? Well, this is what gave me so much trouble back then, so let me explain. When I first used buttons, by intuition I just wired them to 5 volts so that if my code detected they were high, I knew the button was being pressed. However, notice that when unpressed, the pin isn't really connected to anything. Well, fine, it'll just read low, right? Well, no, that would be if it was connected to GND. It actually goes into a chaotic superposition of high and low and wreaks havoc in your circuit. And to solve this, we use pull-up resistors. Pull-up resistors are some internal resistors the Arduino has which are tied to 5 volts. So if you enable them for any pin, that pin's default state will be high and you won't get any more noise. And that means, in this case, if we wired our button to 5 volts, the pin state would be high when unpressed and high when pressed. Not very useful, is it? So we wired it to GND instead, so the pin state is low when pressed and high when unpressed. Problem solved. Now, you could also use pull-down resistors, so resistors tied to GND, and use high for the button being pressed, which could be more intuitive, except the Arduino doesn't have internal pull-down resistors, so you'd have to wire them yourself, and I have no idea when you would do that. Anyway, let's get coding. So, the first thing we'll do is set our pin modes. I chose pin 4, and as you might have guessed, as we are receiving data from the button press instead of sending data, it'll be an input pin. However, here's where we also need to define if we want any pull-up resistor for our pins. So in this case, instead of input, it'll be input pull-up. So with this mode, we're gonna have pin 4 as an input pin with the pull-up resistor enabled. Nice. So what we want here is to see if our button is pressed or not. And how do we do that? Well, first, we're gonna introduce a variable here at the beginning, and there are many different types of variables. In this case, it's not really gonna matter which one you choose. I'm gonna choose bool. Bool is just a variable which can be either true or false. So I'm gonna do bool pressed. You could also do int, which would be an integer, so a 1 or a 0. But when we look at it, it's actually gonna be a 1 or a 0 anyway, so it doesn't really matter which one you choose in this case. So yeah, here what we'll do is introduce our first new function. Because remember when we use digitalRead to set the state of a pin to either high or low? Well, if we want to read if the state of a pin is high or low, we used digitalRead instead. And of course, as we're not setting anything, we just need to specify our pin. So here what we're actually gonna do is say that pressed is equal to digitalRead 4. So this bool variable pressed, which can be either true or false, will be equal to the current state of our pin. But how do we actually see what this is? How do we actually see the value of pressed in real time? Well, with a tool I introduced at the beginning of this series, the serial monitor. I'm gonna actually open here in Tools, Serial Monitor, and you can click, there we go. And here it'll open, well, right now, of course, I'm not reading anything, so it's completely blank. But yeah, this is incredibly useful tool. It allows you to read all kinds of data from your system. Yeah, really nice. So, to initialize our serial monitor, in the setup, we actually need to use serial.begin. And then, between the parentheses, we're gonna specify a baud rate. Basically just how much data it's gonna be sending, how fast it's gonna be receiving data from the circuit. A good standard is 9600, so yeah, we'll just use this for now. You can here you can also see a lot of different baud rates you can choose from. You can just experiment with this. If you choose higher baud rates, you're gonna just have a ton of data being spammed on the terminal. So yeah, that's up to you. But anyway, we have our serial monitor initialized here, and what we'll do is say serial.print. So here, to just print the value of something to our serial monitor, and what we're gonna print is pressed. So what this is gonna do is print in the serial monitor the current value of this pressed variable. So let's just upload it real quick. Oh no! What is going on? It's all getting filled with ones. Well, this is because of two main problems. First, well, this is actually true. This would be the one which would be the equivalent of our bool variable being true, because remember that the default state when the pin is not being pressed is already high, so it's already true. So what we would want is to do the opposite, because of course pressed is not true right now. So simply in code, when you want to negate something, so do the opposite of something, you write an exclamation mark. So what this simply will do is say that pressed is the opposite of what we read in our pin 4, which means that if we read high, then if we read true, then pressed will be false, because remember that high means that it's not being pressed. And if we read low, so false, then pressed will be true, because when our pin is low, the button is pressed. And secondly, you can see that it's all being just crammed into one single line here, and it's really hard to see because it doesn't even scroll automatically. And this is because we used the normal print command. This is useful for like doing strings of text, in a single line. But here, preferably, we would use printl. And what this will do is for each time it prints the value of our pressed variable, it'll use a new line in our serial monitor, which will be much cleaner. So let's upload this now. And as you can see, in our serial monitor, right now I'm not pressing the button, so this pressed variable is at false, so it's printing 0 here. And if I now press the button, it turns into 1. Not pressed, pressed, not pressed, pressed, not pressed, pressed, not pressed, pressed. Nice! Now, let's add an LED to our setup, connected to any pin, remember the resistor, and we'll control it with our code. Alright, so as before, I will start by setting our pin modes. So pin mode 4, input, pull up, and then our LED pin. In my case, I chose pin 5, so I'll do pin mode 5, and this time output. So yeah, there's our pin modes, and here in the white loop, what we want to do is basically, if we press the button, the LED lights up, and if we don't press the button, the LED turns off. And to do this, we need some kind of condition, and this is where our third new function of the day comes in, the if statement. So the if statement goes like this: if, between parentheses, condition, then between these key thingies, you have the action. Alright? So for example, you could do if 1 is greater than 0, then digitalRead 5 high, for example. So this would always be active because, as far as I know, 1 is always greater than 0. But you could also do, for example, if 1 is less than 0, and this would then not be active ever. You also have greater or equal to 0, which again would always be active, or less than or equal to 0. Oh, what did I do there? Or less than or equal to 0. You also have that. And you can also do exactly equal to 0. Notice that I use 2 equal marks here, and that's because in if statements, if we want to use exactly equal, we use 2 marks instead of 1, just so that we don't confuse it with the variable assignment things from before. So yeah, always remember, if you don't want to get a syntax error, 2 equals for the ifs. So yeah, this would of course never be active because 1 is not 0 in fact, but we could also do negation. So this would be if 1 is not equal to 0. So this now would be active. But these are all, static conditions. We want a dynamic one, which is our button press. So what we'll do is, if digitalRead of our button pin is exactly equal to low, which is the state when the button is pressed, then, yeah, we actually already wrote it here, we will set our LED pin to high. However, we have a problem here, because if with what we have right now, if we press the button once, then this will be set to high, but it won't be set to low again. Now, you could maybe use some kind of timing to, turn it off after a second, for example, but if we actually want to turn it off whenever we lift our finger, we use else. Else, we use it to simply say, so if this happens, then this happens, and otherwise, so in all other cases, which it's really in our case would just be if digitalRead 4 is high, in all other cases, our LED pin will be low. So, yeah, if our button is pressed, our LED goes high, otherwise our LED goes low. Let's upload this. Alright, so now that we've learned to use buttons, let's have some fun. we're gonna make a working mini keyboard. So, we're gonna need 8 buttons, one for each note on the scale. You can use fewer if you don't have that many. And a buzzer. Remember what type of buzzer? Passive, exactly, the one that's not sealed. So now, we'll connect the buttons like before, one to each pin, and our buzzer to another pin. So, we've got a bunch of pins to set. So, for my buttons, I used pins 2 through 9. So, I'll just do pin mode, input pull up, and copy this 8 times. And then just do 2, 3, 4, 5, 6, 7, 8, and 9. There we go, that's my button pins. And then for the buzzer pin, I'll do pin mode. I chose pin 10, which happens to be a PWM pin. And then I'll do output. There we go. So now, for the loop, we're gonna have a bunch of if statements. Alright, so we're gonna do if, say the digital read of our pin 2, the first key, is low, then we're going to do tone 10, and we're gonna start with the frequency of the note C4, which will be about 262 Hertz. And then we'll do, if we just did another if statement for another note, then it would like kind of try to do both at the same time. So remember, here we would need to use else. But how are we going to use else if, we have so many other conditions to set? Well, we can actually kind of divide this else into different ifs. And we do that by doing else if. Simple as that. So, else if digital read. Now the pin 3, which is our next key, low. Then we do tone. Oh, cap lock. There we go. Tone 10, and the frequency for D4 would be 294, more or less. So then we can just copy this for every note. So this one will do 4, and the next frequency would be 330 Hertz, and then we would do 5, and then we'd have 349, and then for our pin 6, the next key, we would have 392, and now I didn't memorize the numbers, don't worry about my sanity, I have them written down here. So yeah, pin 7, we got 440 for the next note. For pin 8, we have 494, and finally, for pin 9, which would be C5, we have 523. There we go. But what if we're not pressing any keys? We wanted to, shut up. Well, we just do a final else for all other cases, which, can only just be nothing pressed. Else we will do, remember, no tone 10. So yeah, if we press the first key, it will be 262, the next one will be 294, then 330, 349. These are just the frequencies of all the musical scale. And if we are not pressing any keys, it'll just not sound anything. So, let's upload this. Isn't that amazing? We've only learned a few components and some basic code, and we're already making a keyboard you can actually have fun with. And let me tell you, it only gets better from here. If you have any questions, feel free to ask away in the comments. Also, please remember to like and subscribe if you found this helpful, so more people can find these tutorials, and I'll see you in the next one.